Hello everybody, I'm Eleonora D'Arnese and today I'm going to present you CHIMEra, that is my PhD work. So nowadays in the hospital framework we have hospitalized patients and normal people that goes to the hospital and needs to have exam done. And what we can see is that for each exam we can have different type of outputs such as signals, images, free text, and all these data are generally processed by physician that has to go through all the data and see if there is some possible of disease, find a diagnosis, a treatment, and so on and so forth. So the problem here is that looking the image part, they are quite common in the hospital fields. So if we go there for X-rays, CT, or different exam, we have tons of image that should be analyzed. So the problem here is how we can optimize this analysis procedure and which of them should be selected for the optimization process. So what I present is a comprehensive approach that aims at optimizing the processing of medical images, and in particular of image registration and segmentation that we can classify as pre-processing procedure, and mass characterization that can be classified as processing. So image registration is a superemployed pre-processing step that aims at aligning two stacks of image and allow for a correct mapping of the data. So if we want to understand better a scene, we want to fuse data, and this is the process. So how can we make this fast, efficient, accurate, and also keep the flexibility of software while exploiting hardware? We can do it with Faber, that is an open source automation framework that allow for the deployment of accurate, efficient, and fast image registration pipeline. So the user can decide whether to deploy the transformation of the images and the similarity metrics in hardware or software, and Faber takes care of the deployment of the actual system. So you just have to choose what you want to accelerate, and we take care of the rest. And you can choose between CPU and FPGA acceleration. In this direction, we have also seen that we can maintain state-of-the-art accuracies also using hardware accelerators. The second step is image segmentation, and nowadays convolutional neural networks are the de facto standard for segmentation. And we have seen that they are generally deployed on GPUs that are power hungry, and so we have found a way to transparently deploy the inference based on FPGAs that are generally more energy efficient. So we can use Nerone, that is an open source framework that allows for the acceleration of the inference of convolutional neural networks on FPGAs. So the user just needs to train their network as usual on GPU. Then we have this model that should be accurate, and Nerone takes care of the quantization and the compilation and the deployment on the FPGA. So the end user just has to write a few more lines of Python code, and the acceleration is managed by Nerone itself. So for the end user, there is no additional cost in using FPGA's accelerator for the inference phase. The last step is mass characterization. So cancer is widely spread in our world, and this last step also can benefit from the previous two, and we have seen how to make a reproducible and reliable mass characterization system. So what we have is generally for screening or detection and diagnosis, we have positron emission tomography and computed tomography that are then analyzed by physician to find if the mass is malignant or benignant, and then the physician has also to make the diagnosis and the treatment. What we want to do is have a methodology and a tool that automatically identifies, segment the tumor, extract radiomic features that are kind of a signature of our tumor, and then we use this radiomic feature to characterize the mass as benignant or malignant, and if it's malignant, if it's primary lung cancer, metastasis, and if it's primary, we can also divide among the histological subtypes. So what we have created here is a kind of in vivo non-invasive biopsy, so we don't need to take the sample of tissue, but we can have an understanding of the tumor directly from images, leaving also to the physician to take care of the diagnosis and the therapy without taking too much effort in the image analysis. So that was all for my part. I thank you for your attention, and if you have any question, you can send me an email.
We can move now to the next presentation, which is given by Modern high-level synthesis, improving productivity with a multi-level approach.